All right, so now we're kind of getting into some of the harder stuff. Okay, so we're going to be talking about using functions and getting input and output values. So function can be represented by an equation, like a rule. An equation will generate ordered pairs by taking an input that results in a certain output. The graph of the equation is the set of the ordered pairs, which often forms a line or a curve. Okay, in this class, we're mostly going to be focused on the lines, not so much the curves, but you're going to get into them a little bit towards the end of this class. Okay, so you have this function. So, and I'm going to show you how this works, but you're going to take the x, you're going to put it into the function, and you're going to get out a y. So you're going to get out an output value. Okay, so this value that you're putting into the function, the x value, is called independent because you can pick it. For example, the hours worked question. You can pick how many hours you work. Like, I mean, they have to schedule you, I guess, but anyway, you are in control of that. Like if they ask people who want to get off early, you can say, no, I want to stay. Like you're kind of sort of in control of that. So you control how many hours you work, and how many hours you work gives you, it depends on, your check depends on how many hours you work. So the y value is dependent because it's dependent upon how many hours you work. So we're going to just kind of cheat with this little function machine here. And I'm going to take this function, x plus 4, and I'm going to use just like some x plus 4, okay? And so we're going to take and we're going to put in this value right here, -5. We're going to put a -5 into this function machine. So if I put a -5 in there, that becomes a -5 plus 4, which gives me a -1. So when I put a -5 in, 1, 2, 3, 4, 5, I get a -1 out. Okay, and then I do this whole thing over again. Delete. So I'm going to still have my function is still x plus 4, but now I'm going to put in a -4 for that function. So I'm going to put it in. So I get a -4 plus 4, which is 0. So I have a point at a -4, 0. And then I put a -2 in. And don't worry, I'm not going to do this every time. I'm just kind of trying to really drive this home. You're putting a -2 in for the x. So you put that into there and you get a -2 plus 4, which is 2. So you have a point at a -2, 2. And then you're going to do the last time we're going to do this. I think you understand this little machine here. So my function is x plus 4. We're putting in 0. So I get 0 plus 4, which is 4. So I have a point at 0, 4. So this thing, it wants you to graph the function. So there's my function. It makes that line. Okay. And so I do, yes, want you to connect them. All right. So if I look at number 2, okay, I'm going to take and I'm going to put a -4 into here. Okay. So I'm going to do 3/4 times a -4 minus 2. Well, 3/4 times a -4, remember that's 4 over 1. That would be a -12/4, which is a -3. Yes, you have a calculator, but I mean, you should be able to do 3/4 of 4 because the 4 divides in there. Okay, but if you need a calculator for it, that's fine. So my point is at -1, 2, 3, 4, -1, 2, 3, 4, 5. So I have that point right there, right? Delete all this. Okay, and so now I'm going to take and I'm going to put 0 in. So I'm going to put 0 into my x, and I get 3/4 times 0 minus 2. So 0 minus 2 is a -2. So I have a point at 0, -2. Okay. And then I'm going to take and put, already did that one. I'm going to put 4 in for x. So I'm doing 3/4 times 4 over 1. Those 4's cancel. right? So don't I have 3 minus 2, which is 1? So 1, 2, 3, 4, 1. Okay, and the reason why I wanted to kind of work this all the way through, this is going to happen on some of these problems. So then the last one is you're putting in 8. So I'm putting in 8 for x. So I get 3/4 times 8 minus 2. So 3/4 times 8, well, that's 24/4. So isn't that 6? 6 minus 2 is 4. But if I look at my graph, 8, I can't go over 8. So you're just not going to draw that point, but I expect you to put it on the table. I do expect it to be in the table. All right, I would like you right now to pause the video, and I would like you to work 3 and 4 and get me their answers. I would like you to work 3 and 4. Okay? So this one I think you can kind of do quickly. 3 times a negative 2, that's a negative 6. 3 times a negative 1 is a negative 3, 0, 3. So I have a point at a negative 2, 1, 2, 3, 5, 6. At a negative 1, negative 3. At 0, 0. And at 1, 3. So it makes a line. The next one's a little trickier. Okay, so if I put a negative 2 in there, negative 3 halves times a negative 2 plus 2. So that would be 6 halves, which is 3. 3 plus 2 is 5. Okay, and then I'm going to put, I'm going to come over here to the side. So then I'm going to put 0 in. Negative 3 halves times 0 plus 2. That would just be 0 plus 2, so that's 2. And then I'm going to put 2 in. Negative 3 halves times 2 plus 2. Well, that's a negative 6 halves. So that's a negative 3 plus 2, which is a negative 1. And then I'm going to put in 4. Negative 3 halves times 4 plus 2. That's a negative 12 halves. So that's a negative 6 plus 2, which is a negative 4. So my points are at a negative 2, 1, 2, 3, 4, 5, 0. Did I lose a negative sign? That's a positive 5. Sorry. Negative 2, 5, 0, 2, 2, negative 1, and then 4, negative 4. So it makes this line that I can't draw. Okay? So you're going to do those. All right. So there's some more graphs, but then there are some that they're not even going to ask you to do graphs. So on this, they're giving you the domain. So my x's are 4, 6, and 8. On these, I like to leave a little room. So this is saying 4 minus 5. So then my y is a negative 1. So I have a point at 4, negative 1. And 6 minus 5 is 1. So I have a point at 6, 1. And 8 minus 5 is 3. So I have a point at 8, 3. It does want you to find the range values. So your range on this question would be just the y's. Negative 1, 1, and 3. Okay? So let's just do that again so you can kind of see the table, and then we'll do a couple of these. So I'm going to put my x's here, negative 1, 0, 1, 4. And then I'm going to leave a little room and put my y's here. So negative 1 times 3 is a negative 3 plus 1, so that's a negative 2. 3 times 0 is 0, so this is 1. 3 times 1 is 3, so this is 4. And 3 times 4 is 12, so this is 13. Okay, so you can write them like that. You can list the range. All right, so what I would like you to do right now is I would like you to do 11, 12, and 13. Pause the video. Do 11, 12, and 13. All right, so if I make my little table, they want me to put in a negative 4, 0, and 6. So I would have 7. Half of a negative 4, so negative 1/2 times a negative 4, isn't that a positive 2? So now I have a point at a negative 4, 9. If I put 0 in, I'd have 7 minus 0, so I have a point at 0, 7. And if I put 6 in, half of 6 is 3. So that would be 4. So I have a point at 6, 4. So those are my points. Okay, on the next one, so I make my table. So here's my x's, and they want me to put in a negative 12, a negative 6, and 3. So if I put in a negative 12, negative 2/3 times a negative 12 over 1. So if I put that in there, that would be 24/3, which is 8. Right? 24/3 is 8, and 8 plus 9 is 17. So I have a negative 12, comma 17. And then I would do 2/3 times 6 over 1 plus 9. So that's negative 12/3, which is a negative 4 plus 9 is 5. And then if I put 3 in, negative 2/3 times 3 over 1, and that would be a negative 6/3, which is a negative 2, so it's 7. So I'd have 3, 7. All right, last one of these. So you have, they want you to put in a negative 3, negative 1, and 5. So 7, a negative 3 times a negative 4 is a plus 12. So that's 19. So you have a point at a negative 3, 19. Negative 1 times a negative 4 is a positive 4. So you have a point at a negative 1 on 11. And 5 times 4 is 20, so that's a negative 13. Okay. All right, so this last thing is just, you have this on your note page. I kind of want to talk about the different ways you can represent it. So you can represent it as a table, which means your x's are your domain, negative 3, negative 2, 0, 1. And your y's are your range, 1, negative 4, 2, and 6. Is this a function? Yes, because none of those repeat. If I go to the mapping, my domain is my x's, my range is my y's. Do any of your x's repeat? So like if I work 5 hours and my friend worked 5 hours, we both could make $100, right? Like you can repeat y's. If you did a dance competition and you danced one dance and then the next dance, you could get the same score, right? For 2 different dances. So it's the y's, they can be repeating. Okay, it's the x's that can't. So this is, yes, a function. Okay. We're going to look at the equations here in a second. Let's go over to ordered pairs. So my domain is my x's, negative 1, 0, 2. My range is my y's, 2, 5, and 7. Is it a function? Yes, because none of my x's repeated. Graph, you're going to go from left to right. So my domain is from 1, 2, 3, is that a negative 4 to 1? Okay, and your range, you're going to go from bottom to top. It looks like from a negative 2 to 3. Is this a function? No, because remember that vertical line that we drew. Okay, if I take this vertical line and I move it, it's hitting twice. Okay, all right, the last one is an equation. So this one I'm not really we're gonna do more of this, but the domain is what you can put in. So can you square anything? You can square negatives, you can square positives, you can square decimals, you can square fractions. So then this is a negative infinity to infinity, okay? Now here is where the range comes into play. If I put in 0, wouldn't that be 0 minus 1, which is a negative 1? If I put in 1, aren't I going up to 0? But if I put in a negative 1, negative 1 squared is 1, 1 minus 1 is 0. So to me, it looks like it's going up from a negative 1. We haven't really gotten into this yet, so this is kind of a tough one, but it ranges actually a negative 1 to infinity because you're subtracting 1 from it. Is it a function? Yes. All right, so you have some homework that goes along with this.